Okay, so here we have an application. We've got the population of Federal Way in 1996 was 72,896, and then in 2016 it was 96,775. We're going to assume that it's linear. It was approximately linear. And we'll let the x values represent years since 1996, and y values represent the population. So what I'm going to do here, I'm actually going to write a couple ordered pairs that we're going to use. If we think about a graph of this, 1996, if x values are years since 1996, 1996 was our year 0. So I'm going to write an ordered pair, 0, comma, 72,896. So this was my 1996 year. And then my other point in 2016 was 20 years after 1996, so that's going to be the point 20, and then 96,775. So this 20 represents 2016. So I'm trying to write the equation of a line that models population growth in Federal Way. And so I'm going to, again, use y equals mx plus b form. And my slope, I can just get using my slope formula. So I'll call this my first point, this my second point. So this will be x2, y2. This will be x1, y1. So 96,775 minus 72,896 over 20 minus 0. So that's going to be my slope. Again, I'm just using the slope formula, which is on your note sheet. I'm going to use my calculator for this top one. 96,775 minus 72,896. That gives me 23,879 over 20 minus 0. It's just 20. So what happened is, over the course of 20 years, 23,879 more people now live in Federal Way. And so I'm going to go ahead and do that division. So 23879 divided by 20. And the answer is 1193.95. I'm going to go ahead and round that answer. It says round population growth rate to the nearest whole number. So I'm going to round it to 1,194. And so basically that's our estimate of how many people per year, by how many people per year the population grows in Federal Way. Writing my equation, I can write y equals 1,194 times x. So however many years go by, it's that many times 1,194. And then I've already got my y-intercept here, so I can do plus 72,896. So this is my answer for A. This will be my equation that models the population growth. So all I need to do is plug in the year, how many years since 1996, and then this equation will give me my the population. So next up, we want to predict the Federal Way population in 2025. So in order to do that, I need to translate 2025 into my XY scheme here. So this is going to be, so I need to take 2025 and subtract 1996 so that I can figure out how many years since 1996 2025 is. So this is going to give me 29 years here. So Y is my population. I've got 1,194 times 29 plus 72,896. So let me go ahead and try that out. 1194 times 29 plus 72,896. All right, so I've got a population then of 107,552. That's 522. So this is our model predicts a population of 107,552 in the year 2025. Okay, so last thing we're going to do, we're asked to graph this equation showing at least 30 years of information. So I think what I'm going to do, let's see, build a little graph here. So I'm going to just make each one of these a year. So I'm going to go 10, 20, 30. And I'll go ahead and label my x-axis here. So my x-axis is time. And so this is 5 years, 10 years, 20 years, 30 years. And then my my y-axis, I'm going to show up to, I know that I need to show past 107,000 because that was 2025. That was 29 years after, so that's almost 30. So probably if I go to 120,000, I should be safe. So I'm going to, how many do I have here? I've got 5, 10, 15, 20, 25, 30 that I'm showing. So I can make each of these 40,000, I'm going to say. So this will be 40,000. This will be 60,000. This will be, wait, that's not going to work, is it? Sorry, I calculated that wrong. So this will be 40,000. This will be 80,000. This will be 120,000. So halfway here would be 20,000 and 60,000 here and 100,000 here. So this is my population. All right, and then I've got 3 points that I can, well, 2 points that I can, well, 3 points I can put on here. So in the year 0, we were at 70, so it's about halfway here. Let's get a different color. So we're about halfway, a little over halfway to 80,000. In the year 20, we were at 96, so something like here. And then in the year 29, we just calculated this here. 29, we have 107,000. So 29, and let's see, halfway would be 110, so it's a little under that. Something like that. So we've got our population, looks something like this. So there we've got an approximation, a model that approximates or estimates the population given how many years since 1996 have passed.